The voltages that we deal with are sufficient to actually break down most non-insulating materials. So that if we tried to insulate 330 kV with a piece of wood, it would have to be a very long piece of wood because it will actually turn that non-conductor into a conducting material. The sorts of materials that are used in insulators for these large transmission lines are porcelain primarily. It's a very good insulator, but we do a number of tricks to make it even better. Quite often breakdown does not occur because the insulator is broken down, but because something has built up on the surface of the insulator. For example, rainwater might bring with it a little bit of salt, and it will cause a salt track across the surface of the insulator. So to avoid that, which is very common by the way, the insulators are made in a cup type fashion, so that they're curved in. That gives a longer surface area on the outside, and then if you look in the inside of the cup, you'll see it's rippled like this. That gives an even longer surface area, so that any arc or any breakdown must go across a very large surface area of a large lineal length before it can reach a conducting material. Now, depending on how high the voltage is, that will determine how many of these cups you put on. So if you look at a 330 kV transmission line, you'll see that there are quite a lot of cups all joined together, maybe up to 2 meters long. Whereas if you come down to a smaller voltage such as 33 kV, you may only see 2 of these cups joined together, and they may be smaller than the 330 because you don't need as much lineal distance from the conductor to the supporting frame, and you don't need the length, the breakdown distance, because 330 is much stronger at punching through than 33 kV.